Hi, today we're going to look at this Unit 6B review examples to prepare for our test that's coming up. Notice I do have my calculator open, and in the calculator I need to make sure that it's in degrees. That's going to be the very first thing you're going to have to do when you're ready to take your test, okay? So I'm going to click on Mode, and then I want to make sure degree gets highlighted. So I'm going to arrow down twice and then over once so that I see degree is flashing. And I'm going to hit enter so that radian is no longer highlighted and now degree is. I hit second and mode, and then I'm ready to go ahead and start doing trig. If I want to test to make sure it's correct and everything's saved, I'm going to do the tangent of 45 degrees, and that should give me 1. Notice I did close my parentheses. I put that seatbelt on, and I got my 1. All right, let's look at number 1. The angle of elevation to the top of a building is 38 degrees. If the angle of elevation was measured 57 feet from the building, find the height of the building. All right, we need to go ahead and draw ourselves a picture because we don't have one here. So let me get a pen. The angle of elevation to the top of the building is 38 degrees. So if I have a building, I'm just going to draw myself a building. Okay, the angle of elevation to the top of the building. So that means I must be like off to the side somewhere, and I'm looking up at the building. That angle of elevation, so looking up, this angle right here is 38 degrees. Okay, the angle of elevation was measured 57 feet from the building. So I'm standing right here, 57 feet from where the building is. So the distance between me and the building is 57 feet. Find the height of the building. So I'm trying to figure out how tall this is. And remember, height, even if my building isn't built very well, height is still always measured at a 90-degree angle. So I do have my right triangle. I'm ready to do my trig. All right, so I need to figure out where I'm standing. I'm going to be right here at that 38-degree angle because that's my acute angle. Coming out of that angle, I know is my hypotenuse and my adjacent side. So I just need to know which is which. My hypotenuse is across from that right angle, which means the other side coming out of my smiley face is the adjacent. And the one that it's yelling at all the way because it's on the opposite side of the room, right, is the opposite side. So katoa. All right, let's circle the two sides that we are working with. I am trying to find the opposite side. I know my adjacent side. So the one that has 2 check marks is going to be tangent. So I'm going to do tangent, and then I need to decide, am I doing regular cross multiplication or am I doing inverse? So when I look at this one, I can see I'm trying to find a side. So for side, we're going to do cross multiplication, not the inverse. So I'm going to put the angle right here. Tangent of 38 degrees is going to equal this ratio opposite over adjacent. My opposite side is x, and my adjacent side is 57. Put the left side over 1 so that we can cross multiply. X times 1 is just x equals 51 times the tangent of 38. 51 times the tangent of 38. This is ready to go in the calculator because it says x equals. So 51 times the tangent of 38, I'm going to close that parentheses, put your seatbelt on, and I get x equals 39.84, and I'm going to go with 6 because that 5 is going to bump it up, 0.846. And we know we are measuring everything in feet. So not a super tall building, 39.846 feet. Okay, let's look at number 2. Suppose a kite is being flown with 375 feet of string. If the kite forms an angle of 50 degrees with the level ground, how high is the kite? All right, so let's draw this picture. I am flying a kite. Here's my kite. I have 375 feet of string. 375. And we form a 50-degree angle with the ground. So this angle right here is 50 degrees. How high is the kite? So what is this distance to the ground? Okay, let's label our triangle and find out. So I'm going to put my smiley face at the acute angle. And coming out, I know, is my hypotenuse and my adjacent side. Across from my right angle is my hypotenuse. And the other side that comes out of the smiley face is the adjacent side. And then my smiley face is yelling to the opposite side of the triangle because they're far away. So I have to yell so they can hear me. Okay? All right, so Katoa. And let's see what two sides we are working with. I know my hypotenuse is 375, and I'm trying to find the opposite side. So the trig function that has my two check marks is going to be sine. So I know I'm going to be working with sine. Am I trying to find an angle with inverse, or am I going to cross multiply because I want a side? I'm looking for a side, so I know I'm going to cross multiply. Sine of the angle, 50 degrees, is going to equal the ratio of the opposite side to the hypotenuse. My opposite side is x. My hypotenuse is 375. So then I can put this side over 1 and cross multiply. X times 1 is x. 370, oops, that should be 75. 375 times sine of 50. So now I have x equals, so I don't have to divide because there's nothing being multiplied to x, so I can go straight to my calculator. 375 times the sine of 50. I'm going to put that seatbelt on. And when I do that, I get that x equals 287.2. And then I have a bunch of sixes before I get to another 2. I'm going to go 6 and 7 because that's going to bump that up. So 2, 6, 7. And again, we're working with feet of string, so I know I'm feet above the ground. Okay, let's go look at number 3. Find the perimeter of the shaded triangle. Notice I don't have any of my angles, which means I'm not going to be able to use trig on this problem. So I'm going to have to think back to Unit 6A or other things I know about triangles. But the first thing that I do see is I have this little triangle right here. And this little triangle I know is a right triangle where I have 2 of my sides and I'm missing 1, which means I can use the Pythagorean theorem. I know the screen's a little hard to see. To find that third side. And that third side is the hypotenuse of that triangle. So when I look at my formula chart, which remember you will have access to when you take your test, when I look at the formula chart, I know if I'm looking for a hypotenuse, inside my square root, I'm going to be adding. My other 2 sides are my 9 and my 12. I usually put the bigger one in first, so 12 squared and 9 squared. So that hypotenuse of that light green triangle, I'm going to come over to my calculator and do the square root of 12 squared plus 9 squared, and that's going to give me 15. So I already found this side. This side is 15. I'm trying to find the perimeter of this blue triangle. So, well, let's look at just that left side. If I look at this side here, I can find that side just using the segment addition postulate because I know that these 3 segments together are making up the 28, right? So I have 28 and I have 9 and 8. I need to figure out what I still need for this piece so that all together they make 28, right? So I'm going to do 28 and I'm going to take away the 9 and I'm going to take away the 8, and what's left is going to be this little piece here. So 28 minus 9 minus 8 is 11. So I know this piece here is 11. So that my 9 plus my 11 plus my 8 makes this whole side 28. So now I've got 2 of the 3 sides of that triangle. I just need this third side. So I'm going to have to figure out a way to figure out what is that third side. How long is this piece? Okay, well, if I draw here, I have another right triangle. I'm just going to re-sketch it over here. Where my bottom here is still 12. My side here is 11 on top and 9 on the bottom. So that whole side is 11 plus 9, my segment addition postulate. That whole side is 20. And look here, I'm looking for another hypotenuse for this third side. We can find the hypotenuse, right? That's easy enough. My hypotenuse, I know I'm going to add in my square root. My two sides are 20 and 12. I usually put the bigger one in first. Let's figure out how long this hypotenuse is. So the square root of 20 squared plus 12 squared is going to give me 23.324. Okay, 23.324 is how long this piece here is. 23.324 for that piece there. So now when I want to find the area or the perimeter around this triangle, the perimeter of this shaded triangle, my perimeter is going to be my three sides added together, my 15 plus the 11 plus the 23.324. So my total perimeter, 15 plus 11 plus 23.324. That gives me 49.324. And I don't have units here, so I could just put a U for units if I'd like. Okay, so remember, you can't forget your old skills. You still might need to use Pythagorean theorem on this triangle, or on this next test. You might even come across some special right triangles that you might be able to work with. Okay, let's look at number 4. The angle of depression from the top of a building to a bird on the ground is 45 degrees. If the building is 150 feet tall, how far is it from the top of the building to the bird? Okay, let's draw ourselves this picture. So I have the angle of depression from the top of a building. Oops. So I'm going to draw my building to a bird on the ground. So I've got a little bird over here. I don't know how to draw a bird. There's its wings. I don't know. And a little beak. Okay. All right. So the angle of depression, that means if I'm looking straight out from the top of the building, the angle of the depression is going downward. Oops. So this angle here, looking down, is 45 degrees. What's great is the angle of depression outside up here is the same as the angle of elevation when the bird looks up at the building. So I still get an angle inside my figure, which is where I want it. The building is 150 feet tall. How far is it from the top of the building to the bird? So I want to know from the top of the building to the bird, what is that distance there? Okay, now this one I can use trig because I can come over here and I can label my triangle with, if I put my smiley face here, I know coming out of my smiley face is my hypotenuse across from that 90-degree angle and my adjacent. And then across from that is my opposite side. Okay, so I can use trig using opposite and hypotenuse, but I see that I have a 45-degree angle here, and I know in a 45-degree triangle, 45, 45, 90, my two legs are both the same. So if this one's 150, this one's 150, and my hypotenuse is that leg, square root of 2. Okay, so I don't have to bother using trig because I can figure out it's 150 square roots of 2. That's my answer. If I don't see that, if it's multiple choice and I see all decimal answers, then I just come over here and I say 150 square roots of 2, and hit enter. And I know that this rounds to 212.132. Okay, I could have done trig with my opposite and my hypotenuse, which would give me sine, where my x is on the bottom, so I know I would need to divide because denominator divide. So it would be that 150 divided by the sine of 45. And notice I still would get the same answer, but I didn't need to do my trig because I remembered my special right triangles. Okay, all right, come on back for the next video and we will start with number 5 on our review examples. All right, thank you so much for watching.